Okay, so welcome to the high GCSE Maths class. We'll be covering the more grade 8, grade 9 questions in this, and it'll build on what you did in the foundation maths class yesterday. So stuff like with trigonometry and Pythagoras, we're going to do the 3D version of it. We've got non-right angle triangle, sine rule and cosine rule, vectors, circle theorems, and so on. So we'll just get started because there's quite a few questions to cover. Again, it will be quite fast-paced, but it'll get recorded, and all the notes will get sent out as well, so you can follow back as well. Okay, so let's get started. So the first one's 3D trigonometry as well as Pythagoras. So what this is spotting the 2D shapes within the 3D shape. So let's have a look at this one. The diagram shows a cuboid A, B, C, D, E, F, G, H, which is just all the vertices. A, B, C, D, E, F, G, H. It says AB is 5 centimeters. Let's start labeling the diagram. So we know this is 5 centimeters. A to E going up is 6 centimeters. AG is 12 centimeters. Now AG is essentially in the middle of the cuboid. So you can see AG is this diagonal over here. So that's AG. So it's going diagonally straight through. So AG is 12. I'll try writing that on. That's 12 centimeters. That diagonal that's there. Okay. It says calculate the length of AD. So AD is this back one over here. So I'll just highlight it. That's what we're trying to find. I'm just going to call that X, so the unknown. That's what we're trying to find. So we're going to have to use what we've got to be able to find out AD. Now, what I would recommend when you're doing 3D trigonometry is draw out the shapes. It just makes it a lot easier to visualize. So for example, with AD, I could pull out AD. Let's pull out this way. I could pull out this triangle here. Let's see. So sometimes it's about trial and error as well. So I could pull out this one here. So I'm going to draw it here. So it's a right angle triangle where the bottom here, that's AB. So label the vertices and that's AD. AD is what I'm trying to find. So I'm going to call that X. I know AB is 5, but I don't know what DB is. So DB, I've got no idea what that is. I need to use a different triangle to find out what DB is, potentially. Okay, so what else do we know? We know this is 6 and 5 over here. So this would be 6, 5. That's not really going to help us. This AG diagonal might help us. So submit this. Okay, so this diagonal might, I guess we'll use this AG here that might help us. So AG, let's draw that triangle. So this is AG going down to C, which is here, and then A to C over here. So AC is the diagonal that's under here like this. So we potentially might be having to use that one then in that case. So this one might not work. So let's try this one. So AG, we know that's 12. That's down the center. GC, do we know this length here? Well, it's the same as EA here that we know is 6, right? So this is 6. And then AC, that's what we're trying to find. So what rule would we use to find this bottom length over here? AC would use Pythagoras. It's not SOHCAHTOA because there's no angles. So we're going to be using Pythagoras. So A squared plus B squared equals C squared. Let's label the triangle. So C is always opposite the right angle. Then we've got A and B. So we've got A squared, 6 squared, plus B squared, we don't know that, we're trying to find that, equals C squared, which is 12 squared. So to find B, we're doing 12 squared minus 6 squared, and then we're square rooting it. So that's what we're doing to find B. So to find length AC in that case, when you put that in your calculator, you end up getting, I'll just put that in my calculator, root 12 squared minus 6 squared. You get 10.392. I'll do it to 3 decimal places just so I don't get any rounding errors. Okay, so I found AC. Now we're going to use that AC to help us. So we can't use what we originally said in the beginning because we've just found AC. So let's use that. So I'm going to delete this. Rub that out. We're going to use what we've just found. So we found AC over here, which is that length there. We found that one. So now I'm going to pull out this triangle on the bottom. So it's quite hard to visualize it, but it takes practice. So this triangle on the bottom, I'm pulling that triangle out to find out AD. So let's draw that triangle. I'm just going to draw a right angle triangle. There's a right angle. Now that right angle is at D over here, right? And then this would be DC, where the hypotenuse is AC. So that's going to be A. Okay, let's label on here what we know. Now AC we've just found over here, so I can label that 10.392. DC, do we know that? Well, we know AB is 5, so then DC must also be 5 as well. So that's 5. And then AD, that's what I'm trying to find. Remember, I've called that X. So now I can work out what AD is, again, using Pythagoras. So let's label the triangle. So opposite the hypotenuse, that's C. And then these ones just label AB. Plug everything into the formula. So we've got X squared plus 5 squared equals 10.392 squared. So therefore, X equals minus the 5 squared, so 3.92 squared minus 5 squared, and we square root all of it. And then putting that in the calculator, we get 10.392 squared minus 5 squared. So we get 9.112, 3 significant figures. So they've asked it for 3 significant figures. So 9.11. So you can see it's a bit of trial and error with these shapes. So the first shape that I chose didn't work, but then we saw that we've got AG. We pulled out AG, worked out AC, and then we used that AC to work out the bottom triangle. And we found the length of AD. Okay, let's do another one. So the diagram shows a pyramid. Okay, the diagram shows a pyramid. The base of the pyramid is a square. Now, the relevance of them telling you the base of the pyramid is a square is that all 4 lengths are the same size. That's the reason why they've told us it's a square. It says AB is 5, so then we know all of them's 5, just like we said, it's a square. The point E is 10 centimeters vertically above the base. So what that is saying is, if I drew a straight line down, going straight down to the bottom of that square, that full length is 10. I'll just do it in a different color so you don't get confused. That's 10 centimeters. It says calculate the size of angle EAC. So where's angle EAC? So EAC, I'm essentially drawing a line like this because EAC is this angle over here. So you have to kind of visualize the shape that's sat inside it as well. Okay, so what could we do here? Let's pull out this triangle that we're working out the angle for, right? So if I draw that triangle, so this is the angle I'm trying to find. So that's at A. That's what I'm trying to find. The red one that's on the diagram, I'll make it red so you know it's corresponding to the diagram. That's what I'm trying to find. That's point A. This is E. This over here is not labeled on the diagram, but I'll just call it a different letter. I'll call it M. So M just means middle. It doesn't matter what you call that, but it's just to help you when you pull out these triangles. So that's M. Do we know any of these lengths? Well, we don't know AE. We also don't know, oh no, we know EM. We know E to M is 10. We know this is 10. And we do not know what AM is. So we've not got enough information to find out that red angle. So we're going to have to pull out something else. Well, I can spot there's a right angle triangle here that I can pull out that can help me find out this length over here. And then we can half it to work out this length over here. So let's do that. So I'm going to draw that triangle out. Again, label it so you can visualize where it is. This is point A, which is here. This is point D here. And this is point C. There's a right angle triangle. We know that this is 5 and that's 5. And this is what we're trying to work out. What would we use here to work out? We would use Pythagoras. So A squared plus B squared equals C squared. Let's label the triangle. So this would be AB, and then C would be opposite the right angle. Plug everything in. So we've got 5 squared plus 5 squared equals C squared. So C would just equal the square root of 5 squared plus 5 squared. And putting that in the calculator, square root of 5 squared plus 5 squared. We end up getting 7.071. Yeah, I'll just give it to that much. Okay, so we've worked out length AC. AC is 7.071. So we've worked out that full length over here. That's 7.071. Now, if I just want AM for over here, remember we're always referring back to the original diagram. If I want AM, I know M's the middle, right? So I just need to half this to find out what AM is. So half of that, so I'm going to say AM is a half of 7.071, which gives us a half is the same as dividing by 2, by the way, so you could have just divided by 2. 3.5355. So we know this over here is 3.5355. Okay. What can we do now? We can actually find the angle now. So we've got two sides, which works. We just need to use SOHCAHTOA to find the angle. We can't use Pythagoras to find an angle, right? That's SOHCAHTOA we're using. So we're using SOHCAHTOA. Now let's label the triangle in terms of O, H, and A. Now H would be opposite the right angle, which is here. A is next to the angle, which is this one, and then that's O. Which two lengths do we have? Well, we've got O and A. We don't have H, so we're using TOA. So we're using tan of the angle, which we don't know. I'm going to call it X. We always call unknowns X, but it doesn't matter what letter you call it. So tan X is opposite, which is 10, divided by the adjacent, which we just worked out, 3.5355. And remember, when you're working out the angle, to pull out this X, we do the inverse. So we're doing tan to the minus 1 of 10 over 3.5355. Putting that in the calculator, we get tan 10 over 3.5355, and we get 70.529 degrees. I'll just do it to one decimal place, 70.6. And that's my answer. So it's using the shapes that's inside the 3D shape to work out what length you need to work out. And you need to figure out as well, like, when am I using SOHCAHTOA, when am I using Pythagoras? A bit of what was covered yesterday, Pythagoras is just for lengths. SOHCAHTOA is for lengths and angles. And they're both for just right angle triangles. Okay, let's have a look at another one. So we've got a triangular prism here now. It's labeled all these in the diagram for us already. So CD is 20, AD is 30, and angle FDC is 35. Okay. Calculate the size of the angle the line AF makes with the plane ABCD. So calculate the size of the angle, the line AF. So where's AF? AF is here. Over there, right? So AF's like going straight through the prism. So the line AF makes with the plane ABCD. So essentially what it means is a triangle's drawn like this. Bit hard to do without a ruler. So that's the triangle you're looking at. That's slotted right down the middle of the prism. That's what it means when it says the plane. So it's touching there. So this is the angle I'm working out here. That's in the middle. So I can draw that triangle out. So let's draw that right angle triangle out. It's always better to draw them out. It's quite hard to visualize it just inside. So that's A, which is here. This is F, which is here. And then this is C. There's a right angle triangle. Do we know anything about this? Well, we know this is what we're trying to find. So I'll call that X. What else do we know? We don't know anything else. We don't know FC. We don't know AC. And we also don't know AF. So we're going to have to use the other ones to help us. Well, I can see there's a triangle here that we could use to help us find CF that we need for this as well. So let's pull out that triangle. So this is triangle on the side, DCF. We know this is 35. We know the bottom of this is 20. And this is what we're trying to find. We're trying to find FC. So we can't use Pythagoras because we don't have two lengths, but we've got an angle. So we're going to use SOHCAHTOA for this. So using SOHCAHTOA, let's label the triangle. So our H is opposite the right angle, which is here. We've then got adjacent next to the angle, which is there, and then this is opposite. Which two sides are we going to use? Well, we've got A, and we need to find FC. So we're going to use something with O and A in, which is TOA. So we're going to use TOA. Okay, so we get tan of our angle, which is 35, equals opposite, which I don't know. I'll just call it FC, with length FC, which we're trying to find, or CF, it doesn't matter. Over A, which is 20. So to work out FC, I need to times by 20. So FC equals 20 times tan 35, because we're dividing, so the opposite to bring it up is times. So putting that in the calculator, you get 14.004. Keep it to 3 decimal places just so I don't get rounding errors, because our final answer is to 3 significant figures. Okay, so we found FC, so I can put it here, 14.004. we still don't have enough information to find out x on this diagram, so we need to use something else. Well, they've given us 30 over here, so maybe that could help us. So I can see a triangle here now. So I can see using AD and using DC, I can use them two to find out AC, which is on the bottom here, and then that'll help me to find out the angle X. So let's pull out that triangle. I'll draw it over here. Okay, so we've got a right angle there. This is ADC. What do we know? We know AD is 30, so put that on here. Always remember when you're drawing these triangles out as well to label each corner with the letter, the corresponding letter, just to make it that bit easier as well. Okay, so we've got 30 on the bottom. We know this side is 20, and this is what we're trying to find. We're trying to find AC. What would we use to find it? We're going to be using Pythagoras in this case. We're not given any angles, so we're using Pythagoras. I'm just going to do this down here. So using Pythagoras, label it ABC. C is opposite the right angle, then this is just AB, no matter which one's AB. Plugging it into the Pythagoras formula, we've got 20 squared plus 30 squared equals C squared. We don't know what C squared is. So to work out C, I'm just doing the square root of 20 squared plus 30 squared. And for that, we get, I'm just trying the calculator. We get 36.06. Put that on the bottom here. So we've just worked out AC. We worked out AC, which is 36.06. So we can label that over here as well. So this is 36.06. Now we've got enough information on the original diagram to work out that missing angle X, which is what we wanted in the first place, right? That's what we're trying to find. So let me just drag this down, get some space. Okay, so now we're going to be using SOHCAHTOA on here to work out what is angle X. So do this in red. So we're using SOHCAHTOA. Label the triangle with H, O, and A. So H is opposite the right angle. We've got O, which is opposite the angle, and then we've got A, which is next to the angle, adjacent. We've got O and A. We do not have H, so we're going to be using TOA. So tan of the angle, which is X, we don't know what the angle is, equals O, which is 14.004 over 36.06. And to work out what X is, we need to do the inverse of tan of 14.004 over 36.06. Putting that in the calculator, we get 21.2 degrees. That's your final answer. Sounds sensible as well. So 21.2 degrees. So yeah, that was quite a tricky one because if you don't understand what the question's asking, what angle it's asking for, so it says with the line AF, with the plane ABCD, then it's tricky to work out what you're doing. But yeah, with all these right angle ones, it'll always be Pythagoras and SOHCAHTOA that's inside, and you have to find out the 2D shapes. Okay, let's move on. So moving on to cosine rule, sine rule, and area of a non-right angle triangle. So just want to explain how you label a triangle before you actually do this. So when you've got a non-right angle triangle, so let me just draw a non-right angle triangle. Okay, so this doesn't have a right angle, so we cannot use Pythagoras and we cannot use SOHCAHTOA. So what we use is we're going to use the sine rule or the cosine rule. You're given both of these in the formula booklet, so you don't have to memorize them, but the more you use them, you just tend to memorize them anyway. Now, the most important thing with these two rules is labeling the triangle as well. So capital letters represent angles and lowercase letters represent the lengths. So if I call this angle A, and this is angle B, and that's angle C, so notice how they're all capital letters, the corresponding sides is the length of that letter. So for example, this one over here, so this is angle A, so this here would be length A. This is angle B, so opposite that one is length B. This is angle C, so opposite that one is length C. So notice how they're lowercase letters. So in the sine rule and cosine rule, the lowercase letters represent lengths and the capital letters represent angles. And remember, whenever you've got sine, cos, or tan, you can only put an angle next to it. So there's no such thing as doing sine of a length, for example. is always of an angle. Okay, so what is the sine rule and the cosine rule? The cosine rule is a squared equals b squared plus c squared, that'll be there, minus 2bc cos a. So you can see for the cosine rule, we need 3 lengths. So A, B, C, it needs the 3 lengths. So you might be working out one of them. And it only needs one angle. There's only a capital A in there. There's no capital B or capital C in that. So understand the rule as well. Now with the sine rule, you'll see 2 versions of this rule, depending on whether you're working out the length or the angle. If you're working out length using the sine rule, the version you're going to use is A over sine A equals B over sine B equals C over sine C. So it's the length, you can see the lengths on the top, the little letters, over sine of the angle. So you can see there's the angles, the capital letters there. Now, if I'm working out the angle instead, just to make it, the reason why you use 2 different versions is just to make the rearranging easier for yourself. So if you're finding an angle, you just flip all of them over. So you would use sine A over A equals sine B over B equals sine C over C. So they're just flipped over, depending on what you're trying to find. To be fair as well, there is another version of the cosine rule you could know as well to work out cos A, but we'll come on to that. Let's have a look at some questions. That's all the basic stuff that you need to know about them before jumping into it. Actually, there's one other rule as well. I've not told you how to work out area of a non-right angle triangle. So you're usually used to just working out a right angle triangle area. So let's say that's 3 centimeters, that's 2 centimeters. You would just do 3 times 2, and then you would divide it by 2, right? Or times by a half. So I'll just say times by a half. So we end up getting 6, we end up getting 3 centimeters squared. So that's how you work it out for right angle triangles. Now for non-right angle triangles, the area is half times AB, so AB, sine C, which is basically what you're doing here. There's half AB. The reason why we don't have sine C in the right angle triangle is because, I'll explain why. If this is sine C, which it is, there's your AB length, and then that's angle C. Sine of 90 is just 1 in a right angle triangle. So essentially what we're doing is we're doing a half times 3 times 2 times sine 90, and we know this sine 90 is just 1, so it's irrelevant to have that. That's why in the right angle triangles we don't have sine C, but it still does work. They're both the same rule. So yeah, the non-right angle triangle, this is the one that you use because you don't always have sine 90, you've got different angles, right? So area of a non-right angle triangle, but it also does work for right angle triangles as well. Okay, so let's have a look at some questions. Okay, so it says, and they'll never tell you as well, you know, like how even with the Pythagoras and SOHCAHTOA questions, they don't tell you which rule to use. You just have to know. Same with these as well. So here we're given a non-right angle triangle first and foremost. So we're not using SOHCAHTOA or Pythagoras. It says work out the length of BC. So BC is over here. I'll just call that X. So we're working that out, give you answer to 3 significant figures. So here I'm using cosine rule, and the reason why I know I'm using cosine rule is because I've got 3 lengths, 1, 2, 3. I'm trying to find X, so that's classed as a length. And I've only got 1 angle. So that's the reason why I know I'm using cosine rule rather than sine rule. Okay, so what do we need to do? We know we're using cosine rule, so I'll just write cosine rule here. A squared equals B squared plus C squared minus 2BC cos A. Always tell the examiner which rule you're using. The next thing is you label the triangle. Now with cosine rule, it's really important that you label your angle first because we've only got 1 angle A in the equation. So the first thing we do is we label angle A, which is that one. So then we can label the corresponding side, which is side A. I'm going to do this in a different color just so you could all get confused with X. So that angle A, so opposite angle A is length A. So this X that we're trying to find is length A. Now it doesn't matter which one you label BC out of the 5 and 7. So I'll just call this B and I'll call that C. But you can do it the other way around as well. It doesn't matter. So now we just need to plug all these numbers into the cosine rule. So we've got A squared, which we've called X. So X squared equals B squared, which is 5 squared, plus C squared, which is 7 squared, minus 2 times B times C, so 2 times 5 times 7, cos of my angle, which is 42. Putting that all in the calculator, and be careful when you put it all in the calculator with the brackets and such, you get x squared equals 21.979, continues forever. So therefore, to find x, I'm just going to square root my answer, right, to get rid of that squared. So the square root of 21.979 gives you 4.69 to 3 significant figures, and that's the answer. Okay, so that's cosine rule. That's cosine rule with the length that we found. So now let's use cosine rule to work out an angle. So work out the value of x, give your answer to the 3 significant figures. The reason why I know I'm using cosine rule is, again, we've got 3 lengths, A, B, C, and we've got 1 angle that we're trying to find. So we're using the cosine rule again. Let me just copy this down. Okay, so we're using the cosine rule again. Now, some people use a rearranged version of this equation, like it'll have cos A first, but you can just still use this version. It'll still work as well. Work out the value of x. First things first, label the triangle. So with cosine rule, label the angle first. So that's angle A. So this would be side A. Then we've got B and C. Don't matter which one you call B or C. I'll just say this is B and that's C. Now plug everything into the equation. So we've got A squared, which is the length, 20 squared, equals B squared, which is 15 squared, plus C squared, 16 squared, minus 2 times B times C, cos of my angle, and I don't know what my angle is, that's x. Okay, so let's work this out in parts. Never just stick all this straight into your calculator, by the way. Work it out in parts when you're doing it. So I'll do it for this one. I didn't do it for the last one. 20 squared is 400, equals 15 squared plus 16 squared, should give you 481, minus 2 times 15 times 16 gives you 480, and then we've got cos x. If you end up just sticking it all in your calculator, you'll end up getting it wrong. Okay, next thing that we need to do is, I'm going to bring this 481 over to the left-hand side. So I need to get x by itself. X is here, so I need to somehow keep getting it by itself. So I'm going to bring 481 over to the other side. Since it's plus, we're going to minus, you do the opposite. 400 minus 481 is minus 81 equals minus 480 times cos x. Now, when you've got minuses on both sides, by the way, and you've only got 1 term on each side, you can just cancel that minus out, by the way. So I can just say 81 equals 480 times cos x. That's only if you've got just 1 term on each side, you can do that. So if I had like plus 2 there, I can't just cancel the minuses out then. Okay. So what can I do now to get cos x by itself? I'm going to divide by 480 first. I'm going to write cos x first. 81 divided by 480. I'll just leave like that. And then finally, to work out x, all we're doing is just the inverse of cos, right? So to pull out this x, so x equals cos to the minus 1. So click shift on your calculator, press cos of 81 over 480. Putting that in your calculator, you end up getting 80.3 degrees to 3 significant figures, and that's your answer. Okay, so that's an example of length and angles with cosine rule, but they can make it a lot harder. They can incorporate algebra with it. So for example, this question here, work out the value of x. This is quite a tricky one. Most likely, if you're doing higher paper, you are going to end up getting something like this instead, rather than them nice ones with just numbers. So let's do this. Anyways, just so you can see how the algebra side of it works as well. So we've got a non-right angle triangle, and it says work out the value of x. So we're going to be using the cosine rule to work out the value of x, because the reason why we're using cosine rule is we've got 3 lengths and we've got 1 angle. Okay, so cosine rule, let me write it down again. A squared equals b squared plus c squared minus 2bc cos a. So you can see with the amount you write it down, you just end up memorizing it. Okay, next step is you label the triangle. So this would be angle A. Always label angle A first with cosine rule. So if that's angle A, this is length A. And then the other ones are just B and C. No matter which one you call B or C. Now, everything that you've got, you're just plugging straight into this formula once you plug it into the formula, you're just solving and finding x, which is the tricky part. So a squared, let's plug everything in. A squared is root 73 squared, right? So that's a, equals b squared. B squared is 2x minus 3 squared. C squared is x plus 2 squared. And then we've got minus 2 times b, which is 2x minus 3. Let me write that 3 a bit better. Times c, which is x plus 2. Cos of angle A, which is 60. Okay, now cos 60, this could also come up in a non-calculator paper. The reason why this is a non-calculator paper question as well is because they expect you to memorize your values for sine, cos, and tan for 0, 45, 60, and 90. I missed out 30 as well. So you need to know them values as well. So for cos 60, I'm just going to put that here. Cos 60 is a half. So if you didn't know, like, have that value memorized, and you wouldn't have been able to do this question, and you lose the marks, unfortunately. So do memorize the trig values as well. So for your non-calculator paper. Okay, so now we need to expand and simplify and collect like terms. So root 73 squared, well, the square root and square cancel out with each other. So we just get 73. That equals 2x minus 3 times 2x minus 3 because it's squared. Then we've got x plus 2 squared, which is x plus 2 times x plus 2. We've then got minus 2 times 2x minus 3 times x plus 2 times a half. Now, the 2 and a half, minus 2 times a half is just minus 1. So I can just say it's minus. I don't need to write the 1 there because the 1 is a bit redundant to write it with 2x minus 3x plus 2. So yeah, I don't really need that 1 there. It doesn't matter if you leave it there, but you don't need that 1. Okay, so we're starting to get a bit more simple. Now we need to expand everything. And you should realize you're going to end up getting a quadratic, so we're going to end up getting 2 answers at the end. Quadratics tends to come up all over GCSE Maths, like somehow they'll incorporate quadratics, even in cosine rule, as you can see here, just so they know you understand that you get 2 answers and you might have to reject one of the answers, but you'll see what happens here. And also the idea as well that whenever you get a quadratic, you must make it equal to 0. So they're testing you that you understand how to solve quadratics. Okay, so 73 equals 2x times, you can use your grid method or you can use FOIL. It's up to you and how you want to expand this, but you should be quite confident on how to expand that. 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. And then we've got minus 6x again because minus 3 times 2x, so minus 12x. Minus 3 times minus 3 is 9. Okay, so we've expanded the first one. Let's do the next one. We've got x times, notice I'm putting brackets around everything and you'll see why. X times x is x squared. X times 2 is 2x, and then we've got 2 times x again, so 2x and 2x is 4x. If you don't feel comfortable simplifying at this stage, you can just write everything out, it's fine. 2 times 2 is 4 for the last one. And then minus 2x times x, which is 2x squared. 2x times 2 is 4x, and then we've got minus 3x. 4x minus 3x is just x. The minus 3 times 2 is minus 6. Okay, so we've expanded everything out. Now I put these brackets in, you'll see why. So 73 equals, now there's nothing in front of this bracket that's affecting it, so I'm just going to write 4x squared minus 12x plus 9. Same goes for this one. I've just got a positive on the outside, so I've just got plus x squared plus 4x. Why have I not spelled that? And then plus 4. Now over here, it affects it. There's a minus in front of here. So that minus is going to affect everything in the bracket over here. So minus 2x squared, because minus times the positive is minus. We've got minus 2x squared. We've then got minus plus x. A minus and positive together give you minus. So that's minus x. And then we've got minus 6. Minus 6. The minus turns to a positive. So we get plus 6. So had you not had this bracket over here, you would have ended up getting the signs wrong. So that's why it's really good practice to put the brackets there. Now let's just collect our like terms. So we've got 73 equals, let's get all our x squareds together. So we've got 4x squared plus x squared minus 2x squared. So that gives us 4 plus 1, which is 5. 5 minus 2, we've got 3x squared. And then let's do our x's together. We'll do a different color. So we've got minus 12x plus 4x minus x. So that gives us minus 12 plus, well, minus 12 plus 3, because 4x minus x is 3. We end up getting minus 9x. And then finally, let's collect our numbers together. So we've got plus 9, plus 4, 13, plus 6, which gives us 19. Okay, so as we suspected, we've got a quadratic equation here. And remember, with quadratic equations, you must always equal them to 0 to solve them. Make it equal to 0 to solve them. So we've got 3x squared, we've got minus 9x, and then I'm bringing this 73 over, so the opposite of plus 73 is minus 73. 19 minus 73 gives us minus 54, and that equals 0. So this is the equation that we're solving. Now I've noticed that 3 minus 9 and minus 54 are multiples of 3, so I can divide the whole equation by 3 to make it easier for myself. So I get x squared minus 3x minus 18 equals 0. So this is what I'm solving. Now it's up to you how you want to solve it. You can use a quadratic formula, you can just factorize it. This one's quite easy to factorize. So let's get our 2 brackets equal to 0. We need 2 numbers at times to give us minus 18 and add to give us minus 3. So it's going to be a minus and a positive number to times to give us minus 18. So we could try minus 6 and plus 3. Let's try that. So minus 6 times 3 is minus 18, and minus 6 add 3 gives us minus 3, so that works. So therefore, with 2 answers, we take the opposite signs. So x equals 6 or x equals minus 3. Now, if you think about it, what is x representing? X is representing length, so these are lengths, right? And it's not possible to have a negative length, so we have to reject the negative answer. And you have to explain why. So we're rejecting this answer because cannot have negative length. Okay, so for 5 marks, our answer is just x equals 6. Okay, so that's just to show you how the cosine rule can get tricky and how they can overlap it with other stuff as well. So let's have a look at sine rule examples now. So we've covered quite a lot of cosine rule. Let's have a look at sine rule when that would come up. So here, work out the length of BC. So you should notice that we don't have a right angle triangle, so we're not using Pythagoras or SOHCAHTOA. We're either using cosine or sine rule. We cannot use a cosine rule here because we don't have 3 lengths. We've only got 5. That's it. We don't have anything to do with these 2, so we can't use cosine rule. So we're using sine rule. So generically, the way I explain it to students is check you can use cosine rule. If you can't use cosine rule, then most likely it's sine rule. So what's sine rule saying? Well, we're working out length. So for length, we're using this version, a over sine a, so the length is on top, equals b over sine b. So we only tend to ever use just 2 parts of the equation. So if you look on what we discussed before, for sine rule for length, I give you 3 parts, but that's just to tell you the rule that all the ratios are equal to each other. We only ever tend to use just 2 of it. We just pull out just that part of the sine rule. So that's what we pulled. We've used the length version. So next step is labeling the triangle. If I call this, let me get a different color. If I call that angle A, wait, what are we working out? Yeah, BC, we're working out this here. So if I call this angle A, that's length A. If I call this angle B, and then this is length B, because the corresponding sides are opposite the angles. Okay, so we've labeled everything. Now let's just plug everything into the equation. So we've got A, which we don't know. That's what we're trying to find. Over sine A, which is sine of our angle A, which is 42, equals B, which is 5, over sine of our angle, which is 53. So this is what we're solving to find out what A is. What's on this side that I don't want with the A? The divide by sine 42 is on that side. So the opposite of dividing by sine 42 is timesing by sine 42. So A equals 5 sine 53 times by this sine 42 that was on the bottom. And then putting that in your calculator, you should get 4.19 to 3 significant figures, because this asks for 3 significant figures. So 4.19. So you can see, compare like how you know whether you're using sine rule or cosine rule. That's what students struggle with the most. Like, how do I know which one I'm using? I can't use cosine rule here because I don't have 3 lengths, essentially. So that's why I can't use it. Okay, so we've looked at a length example. Now let's look at an angle example. So it says work out the sides of angle X. Well, could I use cosine rule? No, because I've only got 2 lengths. I'm not working out this one, so I don't have 3 lengths involved, so I can't use cosine rule. So I'm using sine rule for this. Now the version of sine rule I'm using is not this one. I'm using it switched over because I'm finding the angle. So sine A is going to be on the top. So to find the angle, so it's going to be sine A over length A equals sine of angle B over length B. Now let's label the triangle. If I call this angle A, then this is length A. And if I call this angle B, then this is length B. Just plug everything into the equation. So we've got sine of our angle A, which is X, that's what we're trying to find, over length A, which is 10, equals sine of angle B, which is sine 60, over 15. Again, this could be a non-calculator paper question because they've got that sine 60 then. Sine 60 is one of the values that you need to memorize. So you don't want to learn all the cosine rule, sine rule, soccer power, and then you don't end up memorizing the values. So you just want to be careful of that. Okay, so how do I get X by itself? So sine X equals, I need to get rid of this 10. So the opposite of divide by 10 is timesing by 10. So I'm timesing by 10 up. Sine 60 over 15 times 10. So putting that in the calculator, we end up getting sine X equals, so putting all this in the calculator, we get root 3 over 3. And then finally, to work out X, let me just bring this up here actually. So to work out X, you're using your inverse sign because X is stuck inside there. So sine to the minus 1 of root 3 over 3. So X just equals, putting that in the calculator, 35.3 degrees to 3 significant figures as they've asked for. So that's our answer. Okay, moving on. So, okay, this time we've got area of a triangle now. So remember, area of right angle triangles, you just times both sides and divide by 2 or times by half, same thing. This is a non-right angle triangle, so we have to use area equals half AB sine C. So label the sides. So over here, notice how we've only got one angle in this. So this is angle C. So therefore, the other 2 corresponding sides are A and B. Now just plug everything straight into the formula. So the area equals a half times A times B, which is 9, times sine C, which is sine 30. Again, that's another value you need to memorize. So they could potentially ask you this in a non-calculator paper. So the area, just putting that in the calculator, you end up getting 22.5. That's your answer for the area. So half AB sine C. Okay, so this is it in terms of algebra. So a bit similar to the last example that we had with the cosine rule and algebra. This is with area. So let's have a look at this. So the area of this triangle is 15 root 3. Work out the value of X. Now it's a non-right angle triangle. So we're going to be using area equals a half AB sine C. Let's label the triangle. Now we know this is angle C because we've only got one angle in this equation. And then the other 2 corresponding A and length B. So that's just length A and B. So it doesn't matter which one you call A and B, you'll get the same answer. So that's A and that's B. Now let's plug everything straight into the formula. So we've got half times AB, so a half, times A, which is X, times B, which is X plus 4, sine of our angle, which is sine 60. Again, another value you need to memorize. This could be a non-calculator paper question. Equals, well, we know what the area is. They've told us in the question is 15 root 3. So there you go. We formed an equation. Now we just need to solve and find X. Okay, so what could we do? Let's expand this part here. And what is sine 60? Now you should know sine 60. I'm going to put in the calculator. Sine 60 is root 3 over 2. Again, one of those that you need to memorize if it's a non-calculated paper question. So let me write that down. So we've got a half times x plus 4. Sine 60 is root 3 over 2. And then we've got 15 root 3 here. Now I can bring that half and root 3 over 2 together. I end up getting root 3 over 4 when timesing them together, because 1 times root 3 is root 3, and then 2 times 2 for the denominator is 4. And then let's expand this here as well. So x times x, we get x squared. And then x times 4, we get 4x. And that just equals 15. So we get 15 root 3 for that one. Now I need to just get x's by itself. So I'm going to get rid of this root 3 over 4. Don't expand it out like a lot of people would expand it here, but that's not going to help you. So root 3 over 4, divide it to the other side. So we get x squared plus 4x. I'll show you how to do this in a non-calculator way, just in case this is a non-calculator paper question. If I'm doing 15 root 3, so this is just non-calculator working out. If I'm doing 15 root 3 divided by root 3 over 4, this is just our normal fraction rules, keep, change, flip. So what we're doing is, I'm going to change that first number to a fraction, so I can just put it over 1. If you've got a number, you can just put it over 1. Now what the keep, change, flip says is keep the first fraction, so 15 root 3 over 1, change the divide to a times, and then flip the second one over, so we get 4 over root 3. Now timesing that across, 15 root 3 times 4, well, 15 times 4 gives us 60, so we get 60 root 3, over 1 times root 3, which is root 3, and then these root 3's cancel out with each other because it's on top and bottom, so we just get 60. So yeah, that could be a non-calculator paper question. Now we've got a quadratic. What do we always make quadratics equal to? We make them equal to 0. In that space. So I need to minus the 60 over to the left-hand side. So I get x squared plus 4x minus 60 equals 0. So this is what we're solving. We're going to end up with 2 answers. Most likely we're going to reject one of the answers. So what does that factorize to? I need 2 numbers at times to give me minus 60, but add to give me 4. Now 2 numbers at times to give me a negative number is going to be a positive and a negative number that I need. So it's just trial and error that you're going to have to do. Or you could use a quadratic formula. So 6 and 10. So if I did 6 times minus 10 is minus 60, and 6 minus 10 is not minus 4, is minus 4. So try the other way around. If I do plus 10 minus 6, 10 times minus 6 is minus 60, and 10 add minus 6, which is 10 minus 6, because that plus and minus is negative, is 4, so that works. So that works. So therefore my 2 answers, let me put this up here. My 2 answers is either we take the opposite sign, x equals minus 10, or x equals 6. Now, if you look on the diagram, what we're talking about, x is length, it's representing length. It's not possible to have negative length, so we're going to reject minus 10. I can't have minus 10 centimeters. That doesn't make sense. So I'm going to reject this answer. Get a different color. I'm going to reject. You have to give an explanation because cannot have negative length. Okay, and our answer is just x equals 6. I'll just put it here, x equals 6. That's our final answer. I'm sure we had x equals 6 before as well. That's weird. Yeah, we even had x equals 6 here as well. Strange. Okay, so that's how you use it with the area 1. Work out the area of ABC. Okay, now this is a tricky one. I'll explain why, but I'm not going to finish the question just because of time and I want to go over other stuff, but I'll explain why this one's tricky. Now, it's a non-right angle triangle, so we're using area equals half AB sine C. Now, if I tried to label the triangle, notice how for the area I need 2 lengths. I need A and B. I only have 1 length. I don't have another length. And then sine of an angle, but I've got 2 angles. So I need another length, which is why this equation, I can't use it yet. So what you need to do is you either need to use sine rule or cosine rule to work out another length to do it. So I might just do this question just so you could, it is worth seeing like how we use two rules. So just the mindset, again, just to explain. Area of the triangle is half AB sine C. I can't do it because I don't have two lengths. I've only got one. I need two for AB. So we're going to use sine rule or cosine rule to work out another one. We can't use cosine rule because we're not given three lengths here or trying to work out one missing length whilst given two. So I'm using sine rule. And because I'm working out length, the sine rule version I'm going to use is A over sine A equals B over sine B. Let's label. So I guess we're not finding this length, we're finding this one because it's opposite this. Sine rule is all about what's opposite each other, right? So that's what I'm going to find. So I'm going to label this angle A. So this is length A, angle B, and this is length B. Now remember, this labeling that I've done is just for the sine rule. I'm not using this labeling for that. I'm going to have to label it again when I use area of a triangle. So the labeling I've just done is for the sine rule. And it's because we're trying to find this bottom length so we can use it to find the area. So plugging everything in, A over sine A, which is A, I don't know. Sine of 82, which is angle A, equals B, which I know is 12. I don't know why I'm writing that. So 12 over sine 40. So to find A, I just need to times the sine 82 up because that's the opposite of dividing by sine 82. So A equals 12 over sine 40 times sine 82. I would highly recommend these questions once I'm done this class, like try and putting all these stuff in the calculator yourself, just to see you get the same answers as what I'm getting, because like calculator practice as well. So A equals, putting that in the calculator, you should get 18.487 to 3 decimal places. I don't want rounding errors, so don't round it to 1 decimal place here. Keep a few decimal places. Okay, so we've got A. I know this over here now. Rub that out. I know that is 18.487. So now I can use the area of a triangle. So I'm going to do that up here now. I'll do it in a different color. So area of a triangle now. Now be careful, there's two angles here. You need to be careful what you're using. So if I know this is length AB, so I'm just going to call this is A and that's B, right? The corresponding angles match it. So this is going to be angle B. We don't want angle B, we want angle C. Angle A is this one here. So I don't even want to use that angle. So I can't use any of them angles in this here because that's sine C. So sine C is this one over here that we don't have. But we know angles in a triangle add up to 180, right? So we're using yet again another rule. So angles in a triangle add up to 180. So all I need to do is 82 plus 40, which gives us 122. And then we're minusing that from 180. So 180 minus 122 gives us 58. Gives us 58. So I know this one here is 58. That's my angle C. So again, that's a really common mistake. That's not, they're tricking you. That's why they've put them angles there. We're not using them. So now I can plug everything in. Keep the arrow there so you know where it's coming from. So we've got area, which equals a half, times A, which is 18.487, which we just worked out here, times length B, which is 12, sine of our angle C, which is what we just worked out, 58. Putting that all in the calculator, we end up getting 94.1 meters squared. That's my answer. So yeah, that was quite a tricky one. We were using three rules there. Area of a non-right angle triangle, sine rule, and then also finding a missing angle, knowing that angles in a triangle add up to 180. So yeah, that was quite tricky. So we'll move away from trigonometry now. Let's move over to surds. Now, what is a surd? Let me put this over here. So you should know what the square numbers are. The square numbers. So the square numbers are 1 squared, which is 1, 2 squared, which is 4, 3 squared is 9, 4 squared 16, 5 squared 25, 36, 49, 64, 81, 100. So square numbers, they continue forever. Now, if I square root any of these square numbers, I'll get an integer. An integer just means whole number. So for example, if I square root 25, I'll end up getting 5. If I did root 36, I'll get 6, and so on. So I get an integer, which is a whole number, when I square root any of these square numbers. However, if I square root something that's not a square number, so for example, over here, 3 is sat in between 1 and 4. So if I do root 3, that is an irrational number. It's a number that continues forever. If you put it in your calculator, change it to decimals, you'll see a really long number. So it's an irrational number. So irrational numbers, they tend to be known as ugly numbers. They just continue forever. So in other words, this is a surd. So a surd is something that you square root that's not a square number. So square rooting something that's not a square number is a surd. So if you ever want to identify if a number is a surd, you can put it in your calculator, but if it's a non-calculator paper, list your square numbers. If the number doesn't appear there, then it is a surd. So there's certain rules with surds. We never write them out as normal numbers. We leave them as surds because root 3 is more accurate than writing. So root 3, if I put in the calculator, root 3 is more accurate than writing 1.732050808, and it continues forever. It's not accurate to write the number like that. So we never open up these surds. We just leave them as is, and we do maths on them. So you should know certain rules with them. So it's probably worth saying whenever we're adding surds or minusing surds, the surd has to be the same. So for example, 2 root 3 plus 5 root 3, I can simplify that because they're both in terms of root 3. So it's a bit like saying 2x add 5x, which is 7x. So 2 root 3 add 7 root 3, add 5 root 3 is 7 root 3. Because 2 add 5 is 7, and then we've just got a root 3. However, if I had something like 2 root 3 plus 2 root 7, I can't do this because these surds are different. So we can only collect like terms of similar surds. Another rule that you need to know, if I had like root 3 times root 10, I can simplify that all under one surd. So 3 times 10 like that, which is 30, root 30, which again is a surd. And you can simplify them surds as well. So let's have a look at some exam questions and what they can ask you about surds. That's the background of what surds are. So it says write root 50 in the form k root 2 where k is an integer. So with these questions, they're kind of giving you the answer in the question. They've told you in the form k root 2. So I know that the 50, root 50, I need to write it as something which I don't know times 2 because I've got a root 2 here. Now something times 2 equals 50. We know that's 25. 25 times 2 is 50. If you can't spot that easily, just do 50 divided by 2 and then you end up getting 25. I can split that surd into 2, root 25 times root 2, and you should notice root 25 is a square number. It's over here. And root 25 is 5. So root 25 is 5, so we could just change that to a 5 and then keep root 2 there. So our answer is just 5 root 2. Okay, another one here. It's a bit tricky because there's a number here. But it's the same thing, just ignore that 7's there until the end. So write 7 root 20 in the form k root 5. Well, ignoring that 7 for a second, the root 20, I need to split that up to something times by 5 because there's a 5 here in the answer. Now, what do I times by 5 to get 20? That's just 4. And I can split that surd up just like I did above. Now, notice how the 7 is just following through. I'm just dealing with it as it's going through. So 7 root 4 times root 5. You should notice 4 is a square number and the square root of 4 is just 2. So we've got 7 times 2 times root 5. 7 times 2 is just 14. So we get 14 root 5. So we've put it in the form k root 5 where k is 14. So it's an integer. Okay, so let's move on. Write 3 plus root 5 squared in the form a plus b root 5. Now, it's up to you. You could use a grid method or FOIL method for this. It's the similar to expanding, something like this, it's the same method, but it's just surds instead of letters. So I will do both ways. So if you want to see the grid method or the FOIL method, the grid method, so remember 3 plus root 5 squared is 3 plus root 5 times 3 plus root 5. A common mistake students make is they'll say, oh, 3 squared, which is 9, and then root 5 squared is 5, and then add them together. That's wrong. It's a bracket times another bracket. So I'll do FOIL method first. Hold on, that 5 looks terrible. I'll do FOIL first, and then I'll show you how you do this the grid method way as well. So FOIL says you do 3 times 3, 9, 3 times root 5, which is 3 root 5. Root 5 times 3 again is 3 root 5. Root 5 times root 5 is just 5. The surds cancel out, and I'll explain why. If I had root 5 times root 5, that's the same as saying 5 times 5 under 1 surd, as we've said above with the rule. 5 times 5 is just 25, so we've got root 25, and the square root of 25 is just 5. 25 is a square number, right? So whenever you're timesing two of the same surds together, that square root just cancels out, and that's the reason why. Now, collecting like terms, 9 plus 5 gives you 14, plus 3 root 5, 3 root 5, 6 root 5. That's our answer. Now, I just want to show you how you would do that, the grid method as well, for anyone that does use grid method. So, putting it in a grid, there's your times 3 root 5 times 3 root 5. So 3 times 3 is 9. 3 times root 5 is 3 root 5. Root 5 times 3 is 3 root 5. Root 5 times root 5 is 5, as we've just discussed up here. And then collect like terms. You can see you've got like terms over here, and you've also got like terms over here. So 9 plus 5, which is 14. 3 root 5 at 3 root 5 is just 6 root 5. Okay, so that's how you do it, both methods. Okay, now rationalizing the denominator. Whenever, just in maths, just in general, whenever you've got surds in the denominator, we don't want them in the denominator. We have to get rid of them. Sometimes in the exam question, they won't tell you to rationalize it, but they'll expect you to just know. They might even say simplify. So just know we can never have surds in the denominator, but it's fine if it's in the numerator. Now here, to get rid of the surd in the denominator, as you saw above here, to get rid of the surd, root 5, we just times it by the same thing. Root 5 times root 5 got rid of that square root. So all I'm doing is I'm timesing x over root x by, I'm timesing the bottom by root x, because that'll get rid of the surd on the bottom. But whatever I times to the bottom, I have to times on the top to keep it the same. So I'm timesing by root x over root x. So x times root x with the numerator is just x root x. And then root x times root x, the square root just cancels out, so we're left with just x. Now we can cancel out these x's because we've got one on the top and bottom. So our final answer is just root x. So again, some people get confused saying, well, that's still a surd, but it's not a surd in the denominator of a fraction, so it's fine. We just don't like them in the denominators. Okay, let's try this one. So as you can see with this question just says simplify this. It doesn't say rationalize the denominator, but they want you to rationalize the denominator. They just want you to understand that you understand that. So to get rid of that surd on the bottom, we need to times by root 3. And if I'm timesing the bottom by root 3, I have to times the top also by root 3. So 3 times root 3, so this is a bit like expanding brackets, right? We're doing root 3 times 3, and we're doing root 3 times root 6. Okay, so we end up getting 3 root 3 plus root 3 times root 6 is root 3 root 6. Then for the denominator, we've got root 3 times root 3. The square root cancels out, so we just get 3. Okay, let's see if we could simplify this somehow. So root 3 add root 3 root 6. Well, root 6 isn't a square number, so I'm going to have to combine them two together. So 3 root 3 plus the root 3 root 6 can be written like this. And then 3 times 6 is just square root of 18. So I can just put it like that. And it's all over 3. Now I'm going to see if I'm going to be able to simplify this a bit down. So this is a bit of trial and error. What I'm going to try and do is see if I can split that root 18 into something that will cancel out the 3 on the bottom. If I can pull out a square number out of it. So if we think of root 18, any of the square numbers, so not 1 squared, 2 squared is 4. That's not really going to help with 18 because 18 is not in the 4 times table. We can do 9. 9 is a square number. So we can say 9 times 2 is 18. So split that into root 9 root 2. And the square root of 9 is just 3, so 3 root 2. So I could change this to 3 root 2. So 3 root 3 plus 3 root 2 over 3. Now the mindset for that is I was trying to pull out a square number. And the reason why I wanted a square number was because then I can change it to a normal integer number when I square root it. Okay, now I can split this into 2 fractions. I can say 3 root 3 over 3. So this part here of plus 3 root 2 over 3. So plus 3 root 2 over 3. Now, as you noticed, is I can just cancel these 3's out because it's on top numerator and denominator. So we end up just getting root 3 plus root 2. If you want to put it in number order, root 2 plus root 3, you can do that as well, but you'll get the same answer because root 3 add root 2 is the same as root 2 add root 3. Okay, let's do this one. So it says show that this can be written as root 3. Again, this is rationalizing the denominator question, but notice how with the last questions, we only had just one single surd term. In this example here, I've got an expression. Now, whenever you've got an expression, there's a rule you need to know. So let me just write this out again. 3 root 3 plus 3 over 3 plus root 3. Now, the way you get rid of that surd in the expression is you times by that same expression on the bottom, but you change the sign. So I'm going to put brackets around this as well. I'm timesing by the same thing, but change that middle sign. So it's going to be 3 minus root 3. So if that was a minus in the beginning, then I change it to a plus. So it's always the opposite sign. Now, whatever I times to the bottom, I times to the top, as you already know, 3 minus root 3. So I'm expanding brackets here. So again, you could either use your FOIL method or you could use your grid method, just like we did in this example over here. We're doing the same thing that we did in question 3. So let's expand. 3 times, I'm just going to use FOIL just because it's quicker. 3 times 3 root 3, which is 9 root 3. 3 root 3 times minus root 3. Okay, that one's a bit tricky. I'll do it to the side up here. We've got 3 root 3 times minus root 3. Well, positive times a negative is a negative. Root 3 times root 3, the square root's going to cancel out. So we just end up with just 3 for these two timesing together. And then 3 times this final 3 is 9. So we get minus 9. So yeah, if you struggle doing it in your head, just keep it to the side. There's nothing wrong with doing that. We've then got 3 times 3, which is 9. And then 3 times minus root 3, which is minus 3 root 3. All over 3 times 3 is 9. Now you'll see how the surds cancel out on the bottom and why we times by the opposite sign. So 3 times 3 is 9. 3 times minus root 3 is minus 3 root 3. Root 3 times 3 is 3 root 3. And then finally, plus root 3 times minus root 3. Well, positive times a negative is negative. Do it in parts. Root 3 times root 3, the square root cancels out, so we're just left with 3. Okay, now let's simplify. On the top, minus 9 plus 9, they cancel out. That's just 0, right? And then on the top, we've got 9 root 3 minus 3 root 3, which is 9 minus 3, which is 6 root 3, over 9 minus 3 gives us 6. And then notice how these minus root 3 plus root 3, that cancels out. Minus 3 root 3, add 3 root 3 is just 0. That should always happen whenever you're timesing by the opposite sign. By the way, the surds will cancel out. Now, what you should notice is we've got 6 on the top and the bottom that we can cancel out with each other. 6 divided by 6 is just 1, right? So we're left with just root 3. And there you go, we've just shown that it can be written as root 3. So yeah, they are all rationalizing the denominator questions, but it doesn't tell you in the question rationalize the denominator. They just expect you to know it. Okay. I'm not going to do the next third one because this one's really tricky and I just want to cover something different just for the last 20 minutes. And a bit about quadratics. So these are quadratic inequalities. The reason why it's a quadratic inequality, you should recognize that's a quadratic, something x squared, something x, and a number. We've just seen them in the sine rule and cosine rule questions as well. They can crop up in quite a lot of places. I've seen them crop up in probability, they crop up in working out solutions like quadratic simultaneous equations and so on. So you need to be really comfortable with quadratics, especially if you're doing higher, but foundation do need to know quadratics as well. So we're solving this quadratic. It's an inequality because we've got an inequality sign there, and it's saying solve it when it's more than 0. We need to sketch the graph, and in order to sketch the graph, we need to know where does it cross the x-axis. So we need to solve the equation. So you could use quadratic formula, or you could factorize this one. This one's quite straightforward. So where does this quadratic graph cross the x-axis? Now, before doing that, we know this is going to be a U-shaped or an N-shaped graph. And the way we know if it's U-shaped or N-shaped is we look at the x squared, and we can see this x squared is positive. So this is going to be a U-shaped graph. If it was negative, it would have been an N-shaped graph. So that's positive, this is negative. So it's a U-shaped graph. So we know it's U-shaped. Now let's factorize it. I need two numbers that times to give me 3 and add to give me 4. That's just 3 and 1. So therefore, we take the opposite sign. So x equals -3, or x equals -1. So just take the opposite signs. So this graph crosses the x-axis at -3 and -1, which is on that side of the axis. And it's a U-shape. So it's just a sketch. It doesn't have to be accurate. So it's just to help you. Nope, that's terrible. Okay, so it looks somewhat like that. It's a U-shaped, where this is -1 and that's -3. Okay, so I want to know, where is this graph more than 0? Now, when it's talking about more than 0, it means where is it above the x-axis? So here's the x-axis. Where is this graph above the x-axis? And I can see that it's above the x-axis at this point here and this point here. So that part of the graph is where it's above the x-axis. If it was less than 0, so less than 0 below, then it would be this part of the graph that occurs there. Okay, but it's more than 0. So I need an inequality that represents these two sections of the graph. Now remember, this graph is continuing forever outwards. It just continues going up. So what inequalities can I use to represent them? Well, for this one here, I could say that that part of the graph is when x, so this is x, is more than -1. So when x is more than -1, the graph is up here. It's continuing forever up here. So that's when x is more than -1, because it's going that way. Now when this side here, we could see is continuing upwards that way. It's happening for all x values that are less than -3. Because it's for all x values that way, it's continuing in that direction, not that direction. So it's all about directions of the graph. So our answer is x is more than -1, or x could be less than -3. So it's not both answers, it's either one or the other, because it's going up that way. Okay, so that's that one. Let's do another one. So solve x squared is less than or equal to 100. So remember, quadratics have to equal 0 to solve it. So let's bring the 100 over to the x squared minus 100 is less than or equal to 0. So we've brought it over to the left-hand side. And we want to prove when it's less, we want to solve it when it's less than or equal to 0. Factorizing this, you should recognize this as difference of 2 squares. So difference of 2 squares, because this is a squared, that's also a square number. 100 is 10 squared, and difference means we've got a minus. So the rule for that is the square root of x squared is just x. You put plus in 1, you put a minus in 1, and then the square root of 100 is just 10. So that goes here. So two values is x equals -10 and x equals +10. So that's where it's crossing the x-axis. Is this a U-shaped graph or an N-shaped graph? Well, x squared is positive, so it's a U-shaped graph. So sketching that out, it's crossing at 10 and -10, which is on each side like that. So the graph looks like this. That's 10, that's -10. And this time we want it when it's less than 0. So the above example was when it's more than 0. This is less than or equal to 0. And that's below the x-axis. So this time it's all these values between -10 and 10. And how do we write that down as an inequality? We just say x is between, so less than or more than 10 and minus 10. Now, because there's an equal sign here, you have to put the equal sign on your final answer as well. So with the last question, there was no equal sign underneath. That's why we didn't put it in the final answer. But if it was, then we put it in the final answer. So yeah, that's how you do question 2. Let's have a look at another one. Solve 6x plus 27 is more than x squared. So again, we need to make it equal to 0. It's not equal, but it's either more than or less than 0. But that's the standard rule with all quadratic inequalities. I'm going to keep x squared positive. I'm going to bring everything over to the right-hand side. So I get 0, because I'm going to bring 6x and 27 over to the other side, is more than x squared. And then the opposite of plus 6x is minus 6x. Opposite of plus 27 is minus 27. Now, I don't like it written that way, so I'm just going to push everything all the way around. So x squared minus 6x minus 27 is less than 0. Check that. Yeah, less than 0. Because you can see the pointy part is on the x squared, right? So you're saying all this is less than 0. So that's why you swap it the other way around when you switch the things around. Okay, so that looks a lot better now. Now we need to sketch the graph, so we need to find out where does it cross the x-axis. You can use a quadratic formula or factorize. I'll just factorize this one. So two numbers at times to give me minus 27 and add to give me minus 6. Minus 9 plus 3. So minus 9 times 3 is minus 27. And minus 9 add 3 is minus 6. So therefore, it crosses the x-axis at x equals 9, the opposite sign, and x equals minus 3. And is this a U-shaped or an N-shaped graph? This is a U-shaped graph because x squared is positive. It looks somewhat like this. It's just a sketch, you don't have to be super accurate, but that's 9. And that's minus 3. We want it when it's less than 0. So remember, less than 0 is below the x-axis, so it's just this part here. So we need an inequality that represents all the values of x between minus 3 and 9. So x is less than 9, but because it's less than 9, it's more than, so that way, minus 3. And that's your answer. So just to reiterate, when you've got a finite amount of values, so you can see these values here just between minus 3 and 9, you keep it as one inequality. Even over here, it was a finite amount of values, so it's just one inequality. However, if it's values that are continuing forever, these continue forever upwards, it's all them values. We've got two separate inequalities to represent them. Okay, we've got 10 minutes. I'll do a quadratic sequence question. Now, there's 3 kind of sequences you need to know. You need to know about linear, which is of the form an plus b, so like 3n plus 5. Quadratic sequences are of the form an squared plus bn plus c. So similar to ax squared plus bx plus c, it's just a quadratic where you need to find what's a, b, and c. And then you've got a geometric series where you keep timesing up by a number. So let's have a look at this example. How do we tackle it? So there's a few different methods to do this. So you might have learned a different one in school, but I'll show you the one that I do. Let me write them down. Okay, first things first, we're going to work out the difference between each of these. How do I get from 5 to 11? I add 6. How do I get from 11 to 19? I add 8. 19 to 29, I add 12. And then 29 to 41, I add 12. So usually with the linear sequences, that all should be the same. With a quadratic, they're all different, and then the second one is when they're all the same. If they're not the same on the second one, that's going to be a bit of an issue. You've done something wrong. It's not a quadratic sequence. So the difference between all these ones should be the same. Between 6 and 8 is 2. 8 and 10 is 2. And 10 and 12 is 2. Now there's 3 equations you need to remember that just work. For this one here, you remember 2a equals this number. For this one here, 3a plus b equals this number. And for this one here, a plus b plus c equals this number. So these 3 equations always work with quadratic sequences, so it's just a matter of fact of memorizing them. And we're just solving them to find out a, b, and c, and we're just going to put them over here to find the nth term of the sequence. Okay, let's solve each of them. For this first one, we've got 2a equals 2 So to get a by itself, I need to divide by 2 because that's the opposite of timesing by 2. So 2 divided by 2 is 1. So we found a is 1. Now let's do the second equation. 3a plus b equals 6. We know what a is. A is just 1. We solved it here. So 1 times 3 is 3 plus b equals 6. To get b by itself, I need to minus the 3 over to the other side. 6 minus 3 is 3. Okay. And then finally, we need to work out c. Just budge this up. We need to work out this one now here. A plus b plus c equals 5. And I know what a is. A is 1. And b is 3. So 1 plus 3. I'm finding c. That equals 5. 1 plus 3 is 4. So 4 plus c equals 5. To get c by itself, I just need to minus 4 to the other side. So 5 minus 4 is 1. So all you're doing is you just plug in these into over here. So an squared, a is 1, n squared, plus bn, b is 3, so 3n, and then plus c, which is 1. And this 1 that's here in front of the n squared, I don't really need that. That's like saying 1x. You don't really say 1x, you just say x. So that's your final answer for that one. And that's how you do quadratic sequences. So I'll let you know what a geometric sequence is. So that was quadratic. Linear is something like 3n plus 2. So something an plus 2 looks like y equals mx plus c. So try and relate everything together, linear to linear graphs, quadratic sequences to quadratic graphs, so you can visualize them. Quadratic, we've already said, is in the form an squared plus bn plus c. This one's an plus b. So we could say 3n squared plus 2n plus 6 as an example. These are just examples. And then a geometric is one where you're timesing up by the same number. So for example, 2, 4, 8, 16, 32. This is a geometric sequence because each time I'm timesing by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, where we call 2 the common ratio. They might ask you to work out what is the common ratio. All you do is the number after, that is not the highlighter, the number after divided by the number before. So for example, 4 divided by 2 is 2. You could use any number. Even if I did 32 divided by 16, I'll get 2 as well. So it doesn't matter which one you do, but it's the term after divided by the term before, the corresponding one, like right next to it, not like 2 terms back. Okay. Now I'm going to do one more question. So this is solving quadratic simultaneous equations. So yesterday, foundation class, you covered normal simultaneous equations where there's no squares involved. If there's a squared involved, you have to substitute one equation into the other to get rid of one of them letters. So here we've got x squared plus y squared equals 17, and we've got y equals x minus 3. In order to solve simultaneous equations, we have to get rid of one of them letters. So I'm going to plug this, because it's y equals this, into the y term over there, and then it'll get rid of that y. So we've got x squared plus y squared, and y we know is x minus 3 squared equals 17. So I've just rewrote that top equation just in terms of x, and then I just need to solve it. So we've got x squared plus, expanding this, we've got x minus 3 times x minus 3. That equals 17. Expand that using grid or foil. I'm just going to do this quite quickly because we're running out of time. X times x, x squared, minus 3x minus 3x minus 6x. Minus 3 times minus 3 is 9, equals 17. You should notice we've got a quadratic again. So remember, quadratics, collect like terms, make it equal to 0. It's the same thing over and over again. X squared at x squared is 2x squared. We've got minus 6x plus 9 equals 17. We need to make it equal to 0, so I'm going to minus 17 over to the left-hand side. So I get 2x squared. Have I done something wrong? No, that's fine. Minus 6x. And then 9 minus 17 gives us minus 8. That equals 0. I've noticed 2 minus 6 and minus 8 are multiples of 2, so I can divide the whole equation by 2 to make it easier. X squared minus 3x minus 4 equals 0. To solve that, I can factorize it, use a quadratic formula. So two numbers at times to give me minus 4, add to give me minus 3. Minus 4 plus 1 So therefore, my two answers for x is x equals 4 or x equals -1. Take the opposite sign. Now we found our x's. To find y's, we just need to substitute into one of the equations. You could use a top, but you're just making it harder for yourself, so it's better to use this bottom one here. So I'm going to substitute into y equals x minus 3. Each of these values. So y equals x, which is 4 minus 3. So y equals 1. So I've got my x for that one, and I've got my y. Now do it for the second one. Y equals x minus 3. X this time is -1. -1 minus 3, which is -4. So there you go. I've got my 4 answers. I've got 2 for x, so I've got 4 minus 1, and I've got 1 and -4. And that's your answer for that one. So that's how you do quadratic simultaneous equations. I'm going to wrap up the session there. I hope you realize how much quadratics comes into quite a lot of things, especially with higher. So you need to be really comfortable with quadratics. They come up in all aspects of maths with GCSE as well. So I'm doing the biology class tomorrow. So I'll see you on the biology class where we'll cover some exam questions there as well. And I'll send the recording out for this, yesterday's class as well, and the notes for both foundation and higher.